All right, cool guys. So today, I'm going to repeat, is an arbitrary day. They allow me to talk about anything that I want, but we're going to do a quick recap first, which is of the gesture stuff, because I think last week I explained it, but I don't think me and Tree actually had a discussion afterwards, and I don't think I explained it clearly enough. So I will go over it again. So remember when we created the on-swipe touch listener? So what did I tell you guys about gestures listeners last week? Anyone want to give me a recap? Again? What did I say about gestures and stuff like that? Last week I asked you and you said you didn't know. So what do you know now?
We can control what happens when we touch the screen.
Right. And I gave an example of, for example, when we were detecting how do you create a gesture listener for click, right? And then we did this example where we basically built a swipe listener. But then Tree, do you want to talk about what your research was on? So basically he asked the question is how do you do two-touch detection, right? And the details of that are obviously more difficult than if you have a single touch. But I realized when we were talking about that, I think the explanation of what's going on here in the gesture listener just wasn't good enough. But first of all, let me open this article that Tree was talking about. Tree, do you want to explain?
Yeah, a little bit. This article I have presented at my last company on multi-touch, like because I see that the last lecture from Chris is I think easy with you guys, and I asked him about more complicated on animation. Actually, is on multi-touch. So, did you know? Do you know the action move, action down, right? You know that. That's one, right? Action move and action down and slow down. You know what is the difference between motion event of action up and action pointer up?
Anyone?
Yeah.
Anyone know the difference?
Can
Daniel?
guess the difference between action up and action pointer up?
Action up and
Action pointer up.
I would say I'm not sure what the pointer means in this case.
Okay. Explain.
So we have another couple is action down and action pointer down.
Mm-hmm.
So in case if we have more than one touch, we need to define what is the what is the finger, exactly the finger is still on the screen, and what is the finger is released. You know what I mean? So if I touch two fingers on the atom and I move on one finger and the pointer up, let them know which one is released and which one is still touch on the atom on the map. The pointer down is similar to like which one is down and which one is not down.
Right.
Just a little different, but this different material guys can handle multi-touch.
Right. So this is a more complicated example where you're doing two-touch. But I think one of the things that we started talking about afterwards was how you guys should think about this problem, right? Because the thing is that gestures, I think the way we came to the conclusion that gestures is simply about defining thresholds that you guys want to surpass and a series of events that will allow you to generate your own detection for the things that you want to be sensitive to. Does that make sense? So, how many of you guys know what a state machine is? State machine? State machine. Kind of. No. Yes. 1, 2, 3. State machine. Okay. State machine. This is one of the most important things in computer architecture, computer science. So I'm going to kind of draw this out, right? You have state A, state B, state C, state D, and there's different ways to transition between each one of them, right? And you can say, so usually there's some sort of signal that would cause the state to change. Does that make sense? But these states represent something, right? They represent like the signal represents a transition to a new state, right? So we started me and Tree, what we were talking about though was that the gesture, this on-touch event, the fact that you guys are extending or basically building out your own gesture listener and stuff. Let's see. This on-touch listener. What you're getting in the on-touch is these motion events, right? But did you guys know that this itself is actually a state machine? Just think about it. What are the states? What are the states? The states are what? Okay, let's go back to this, right? The states are these, right? Motion event down, right? So you can just think about it, right? Like, so what Android's doing in the background is that they're creating this higher level of what? My favorite word? Abstraction, right? Because they're sensing your touches, right? Like, so what do they have, right? They have a screen that has like this array of sensors, and from that, like when you put down your fingers, right? They're basically saying they're creating a state machine that says, oh, this person just did a. They're saying they detect based off of how long you press. If it's like a action down, right? A down, right? What else? What else is there? What are the other ones? A move, right? Right? So these are like, this is like a state machine in and of itself. Right? So you can say like, oh, action down, if they're dragging, the action becomes move somehow, right? Based off of your action. Let's say I'm dragging it from here to here. And then up is when they detect like there was something present, it was released, right? So they have their own state machine on top of it. But what you're doing when you're creating your own gesture listener is that you're creating one higher level of abstraction above that. Does that make sense? Right? So you are basically saying, based off of this state machine, I am creating a new state machine. Remember when we were doing swipe, it was swipe left, right? Sorry, can't write. Swipe left, swipe right, swipe up, swipe down, and then what else? Nothing, right? No state, right? And based off of these events, it was going from no state to swipe, right? Basically, right? You're creating your own state machine somehow, right? Does that make sense? So that's what I want you guys to understand. All it is, and you can imagine as it becomes more complicated, if you want to detect multiple, you're creating a higher level of abstraction for your product. So your product probably has different thresholds. Snapchat, for example, they handle a lot of gestures at the same time. So what you're doing is you're creating your own state machine on top of this, right? One higher level of abstraction. Okay, cool. So yes, I think what Tree's point is really good, which is you want to know like the details of what all the things do in the gesture, like all the states that the gesture what the motion events can do. But you also want to like think one level higher than that, which is what am I doing to process the event, and what is the product level action that I want to happen as a result of that. Cool?
Yeah. One more thing is deeper about animation, because some kind of customer want to custom some animation on your app on client app. So you find some library relate then requirement from customer. Then you need to custom some a little bit. Then you read deeper in the library code. But if you don't know about deeper about state machine or about some kind of action down, action up, you cannot customize. Like yeah, that's what I mean. And I want to raise the issue.
Cool. Awesome, guys. Okay. Today, what are we going to talk about? What are we going to talk about? So I'm actually starting out with IntelliJ. So that means today I am talking about dependency injection. Yay. Okay. So why am I doing it in IntelliJ? Anyone tell me?
It's Java, not just Android problems.
So right, it's not just an Android problem. Sorry, I need to close all this stuff. It's not just an Android problem, but even more importantly, and the reason why dependency injection is difficult with Android is because Android already has. They don't use dependency injection from the beginning, right? So what do you have? You guys usually interact with activities, right? You guys interact with activities. You interact with fragments. And for example, you guys used Jake Wharton's the binding, right? What was it called? I forgot the library name. Butterknife. That is actually a form of dependency injection because you're injecting like the view, right? You put an annotation on the view, and it does actually something called field injection. It's basically creating the. But the reason why you can't do it at a deeper level is because there's an entire platform and architecture on it that there's no way to hook in, right? So when you guys play around with Dagger, Dagger is like throwing like dependency injection, but it has to do a lot of hacky things in order to get it to work correctly because you're not using dependency injection from the beginning. And you'll see why this gets complicated in this example. So I want to talk about dependency injection on a pure Java layer first, okay? And I didn't really prepare the Dagger part, but anyways, we'll talk about this. Okay, so there's this guy named Crazy Bob. You guys should all know him. He is the person who created Juice, which is a dependency injection framework created by Google, which is what I'm going to show you. He's also the guy who went over to Square and created Dagger. So he defined this thing called JSR 330. He's one of the guys who defined this, right? Dependency injections, standard set of annotations to use for injectable classes. Okay? This guy's important. Okay, cool. So what I'm actually going to do is I'm going to build from scratch a server that will take HTTP requests. Okay? Actually, not that bad because I have code that I can copy and paste from. All right, so program, public static void main. You guys all remember this stuff, right? Args, right? All right, let's make sure this works. Oh shoot, I should do this from scratch. So let me delete this. All right, just so we're starting. Okay. Okay. System.out.println blah. Okay. Let's just make sure this works. Configurations. Oh, I didn't delete it. Okay, so we'll create a new one. It'll be a new application. Program default package. Terrible name. Okay, click OK. We'll call this one program. Let's see if it works. What's going on? No. What did I not set? Wait, what's going on? This is weird. This is working before. Class is implemented in both. Okay, strange. This is weird. Let's delete this. Apply. Okay. Application. Program. Class module. Okay, cool. That worked. It was just a configuration thing. Okay, I'm gonna call this program. Okay, and let's run it. Cool, right? Printed, right? Okay, so what do we want to do now? So I talked a lot about this before, but what we want to do is we want to just create a port open so that we can listen for requests, right? Okay, so what I'm going to do is I'm going to create a new class called server. And fortunately, so basically it will have a function called start, which will, I'm going to put in a constructor here for now, but I'll tell you guys why in a bit, okay? And the rest I am actually going to copy, because it'll be easier. Okay, so I'm going to copy this start server. Alright, and then I will show you guys the other part after that, sorry. Okay, so, okay, and I'll talk you guys through this in a sec, what this is doing. Okay. All right. Let's. Okay, and then we're going to create a new client task. Which I will also take from here. Class, and then it's runnable. Okay. Oops. Okay, guys. Okay, so we have the server that takes a client task, and let's see what's this else. Let's see. This is this should be public, right? Okay. Cool. All right. Okay, so now we want to introduce dependency injection. Okay. But I could just start this program up by simply saying what? Server equals new server, right? And then server start, right? Actually, let's give it. Let's basically pass in a port. Okay, and then we can say ports. Ports. I don't know, 7,000. Okay, and instead of doing this right now, let's just print something out. Okay. Okay, so first of all, do you guys know what this part code is doing? I'll just talk about this really quick. Okay, so what this code is doing is it's starting a new thread using runnable. It's creating a new thread that's listening to this socket, whatever port that you listen to, and it has a while loop. So this is very similar to the Java handler threads. Remember? It just runs infinitely. That's exactly what a port is similar. Remember how I said there's a few cases in where you just have an infinite loop running over and over and over again? This is one of them. Outside of like drawing for a screen, where a handler thread just has a queue and it just listens for stuff and it sees what it has to redraw. Sockets are the other one, right? You open up a port to your socket and you sit there and just monitor it. And you basically pull off the messages coming off the queue, okay? And then we're going to just print stuff when we see it, okay? So let's run this. Oh, hopstop failed. Stop. Okay, let's debug. Okay, so it's waiting for clients. Okay, so I was already doing this before, but I can curl. You guys see that? Starting to write stuff, right? So we can see that it's getting some data in, or it's receiving the actual request, right? Okay, so now let's introduce dependency injection into this. So right now, did you see how I passed it a thread pool? I assigned it a thread pool up here, right? So this works. Does everyone know what this thread pool does? Does everyone know what a thread pool does? Fum knew, but he's not here. What does a thread pool do? Anyone? Okay. Thread pool.
I think platforms are used to manage threads because resource in computers is limited. So
Right. Right.
And
Yeah. So that's great. That's exactly what a thread pool does. What a thread pool is similar to, it's no different, right? It figures out a way to recycle your threads so that you're not spawning a whole bunch of threads out of control, right? I could say new thread every single time, but that'd be terrible because basically I would be spawning an infinite number of threads potentially if I had if I created 100 terminals and typed HTTP localhost 7000, right? I could literally have 1,000 threads running, and that would totally kill a machine, right? So remember, Java is one of the best things about Java is that you have very good control over threads, which is why so many people use it in production. Okay, but let's add dependency injection so you guys can see how this works. So what I did already in the build Gradle was I added I added this. It's called juice. So who here has used dependency injection before? Dependency injection? No one?
Yeah.
Okay, no one's used. Okay, so people who have used Spring, there's a classic dependency injection architecture called Spring, but the new one that most people use is called Juice for things that are non-Android. Okay, so the way you install it is that you basically just add this. You just add this dependency in, and then what you're going to do is you're going to create something called a module. So let's call this the server module. Okay, and that will extend something called an abstract module, and you're going to implement one function, configure. Okay. In your program, instead of calling new server, you're going to say juice create injector new server module. I'm going to type this through really quick, and then you guys will see. I'll explain the details. And then this will actually create something called an injector. Okay? And then injector, I can call get instance, server.class. This will give me a server instance. And then you call server start. Okay? Okay, so this is a bit of boilerplate code to get started, right? But what's happening here is it's setting up the injector for everything under server. And you're going to see exactly what I mean. Okay, so first of all, let's go back to the server module, the server. So currently server doesn't do anything right now, right? There's no injections. The way injections happen now is that we use annotations, right? Remember how in Android it was like bind view, like that, right? So we don't do that. We haven't done anything like that yet. So let me add this back in. Client processing pool, server, client task, right? So all it's doing is printing got a client, right? And then it'll terminate. Okay, so let me run. I'm gonna run this really quick. Shoot. Do you guys know why it keeps dying? Yeah, so that's part of it, but actually the reason is because you can only have one program binding to a port. And so when I run again, it tries to create a new bind to the port, and that's why it keeps failing. Okay, so let me debug. Waiting for clients. Sorry for all this stuff going on. Let me close all this stuff. I should have done this earlier. Okay, and let's do a curl. And what you're going to see is I got a client, right? Most importantly, this ended, right? Because I did, in the client task, there's a client socket that closed. It closed now, right? Okay. So what do I want to do? The problem here is that in Android, there are some special threads. There's what? There's like the main thread, right? What exactly? The UI thread is a what? The UI thread is a special thread. They also have different priority threads. The same thing happens in backend architectures too, right? I want to be able to like dictate how my threads are created on a very granular level. But remember the way I explained dependency injection before is by calling new thread pool here, I'm basically saying that this server can only use this thread pool, right? I'm creating a new thread pool inside the server class. It basically means I can only use this thread pool here, right? Because it's a private member variable. Okay, so let's move it out. So I'm going to inject an executor service. I'm going to call this, okay? Okay? So remember, previously, the dependency on this executor service, the server actually knew exactly how to create the thread pool, right? It had an allocation of 10, right? Instead, what I want to do is I want to change that, correct? So I am going to bind an executor service.class. I think it's, okay, to an instance, and I'm going to call, oh, sorry, what was the function? It was executor, oops. Do you guys see what I did there? I moved the configuration outside to the injection module, right? So if I put a breakpoint here, and I debug. You'll see that there's a thread pool that's coming in, right? Size 10. Right? You guys see that? And I'll run. And then I will be able to, right? But it works fine, right? Because basically if I look, right, I got client. Okay, interesting, right? Kind of interesting? Okay, but now let's change this even more. Let's say, right now I'm creating a thread pool to handle what? So right now I have all these requests coming in. Let me draw this. What is that? What's the pen? So you have a listener on port 7000. I'm listening to all these HTTP REST requests come in. I have a thread pool that's provided to the server, and I can handle each one, right? So each one that comes in, I handle a thread. But let's say I want to quickly respond to the user and say I complete. Okay, I received your message, but I want to do something in the background. I want to create a new runnable, right? I want to spawn off a long-running task on the server, right? So you guys can think about on Android, when does this happen? This happens is when someone wants to upload, right? If someone wants to upload something, you want to quickly write it quickly into your Realm database and say, okay, it's being handled. And then you have a long-running service that spawns off. A long-running thread that basically continually uploads to the service. Does that make sense?
Yeah.
Curious. You guys seem a little bit lost. Okay, first of all, questions. Questions at this point. I need to know where you guys stand, because this is definitely complicated stuff, so I want to hear where you guys stand first.
About the example again.
This example?
The apply, did you say about the apply example?
Yeah, so imagine if you have a long-running task, right? So no one wants to, if I made an HTTP request, if I didn't call close on that socket, it would literally just sit and wait until I actually respond with some data. But most HTTP requests, you want to simply just make a call, get a response. But anything that's long running, right? Anything that's running for a long time, you basically want to kick that off onto a separate thread, right? Does that make sense? So let's say you have a video processing. You'll get a signal from saying that the video has been uploaded, please process it. You should quickly respond that you've received the task to process the video, but then you should kick off the thread to actually run it, right? Okay, so that makes this a little bit more complicated, right? Because right now we have this client task that implements runnable. Right now we're just simply saying, okay, we got the client, which is great. But what if we want to do something a little bit more than that, right? Right? What if we want an executive service here? What if we want an executive service in the task? Let's say handle video pool, right? Processing pool. So what are we going to have here? We're going to have another executive service, right? And then similarly, let's create this a new task called video processing. Okay, task, which implements runnable. What we're going to do is we're going to make it really simple. We're going to say system out print line start video processing. We're also going to say end video processing. but we're gonna do what? We're gonna sleep. I think it's sleep for what? Let's say 5 seconds. 5 seconds? All right, we'll just surround it with try catch. Okay, do you guys see what I'm about to do? I'm going to make a request. I'm going to respond instantly to that request. But I'm also going to kick off another thread, right? Kick off another thread to handle video processing. Start video processing. I'm imitating what video processing is going to do, which is it's going to do like, I don't know, maybe it'll take longer, right? But for now, it's 5 seconds video processing. Start, end, okay? Okay. And you guys will start to see the power of injection right now. But what's the problem? This is the problem, right? I'm calling new. Remember? What is new telling me? New is telling me that I know how to create this task and I know what dependency it needs. The truth is, I don't know what dependency it needs. So there's something, especially when you want to create these instances per like iteration, they have something called a provider. Client task. Oh. Okay. And inject. Okay. So we'll call this a client task provider. This client task provider, you can call one function, get. Behind the scenes, what it's doing is that, oh, sorry, there's one other thing I need to do, but what it's doing is it's performing the injections for you, right? Where is the injections coming from? It's coming from your module. Does that make sense? Your module now, how were you orchestrating things before? Previously, you were orchestrating things by calling new inside of things. So you can imagine if you have a server has a handler thread has microservices, you were calling new, but how would you have orchestrated it or made a change? You would have to go through every single thing below to do it. Now, I've literally showed you 3 layers. Everything is configured here, right? I've realized, okay, well, I want to handle more threads. I can simply change the thread pool size to a thread pool size of 100 because I'm getting inbound requests and I want to process video on the same thread pool. You can also change it so they have this thing called named. So I can, if I want to like distinguish between, sorry, let's see if I can. Okay, let me do this example first, and then we can talk about like how to specialize. Because right now it's using the exact same thread pool for all of them. So this is the only exception right now, which is that we will have to call set socket. I will talk. There's a more advanced way to handle this, but I won't get to that here. Sorry. Socket, client, socket. This is no longer final, which I can move here. Client task, client socket. That's client socket. So the reason why I have to do this here for now is because the socket is per request. They actually have ways of handling this, but that's much more advanced, right? So let me go back to the server. I call get, and I'll call set socket, client socket. Okay? And what's the one other thing I forgot to do? So right now I'm saying processing. So in my client task, when I call run, I will okay, so this here, and then I have one more thing, a provider or video processing task. Oh, sorry, wrong provider. Is that all making sense right now? Like in terms of code-wise? Kind of. A little bit confusing, right? We'll rehash it, but let me run it to show you that it's working. Oh, shoot, stop. Okay. Debug. Debug. What's going on? Oh, sorry, I forgot to add inject. Sorry, you have to add inject here in order for them to recognize that that they're going to inject stuff on. Okay, let me run again. Okay, so and let's just continue. Okay, so what should we see? All right, what should we see? We should see that we got a client. We should see it return immediately. We should see start processing, and then we should see end processing later, right? Start video processing, 5 seconds, 1, 2, 3, end processing. Did you guys see that? Okay, but now let's go back and sort of, just so we understand what's going on here, right? Previously, the way you created a task was by calling new, right? Previously, the way you created an executive service was by calling new inside of the server. Previously, inside of here, if I want to create a new video task, I would also call new, right? But all of these things that were called new, so all these things that you used to call new on, if they required something, some dependency, you would have to have that dependency available, right? So let's say video processing task required a service. You would literally in your server have to have access to the service, right? And then when you create the client, you would then pass that service into the client, and then pass that into the video task. That's terrible. Can you guys think of an example in which this would have solved everything for Android? Get context. Think about how many times you call get context. You guys are literally passing context everywhere. You guys are passing context infinitely deep because it doesn't use dependency injection, right? Instead, I've literally solved that by having this module here that handles my injection for me, right? I can say whatever dependencies I need. I could come up with a bunch of stuff, right? So let's say for my implementation of video task, okay, it's a runnable right now, but let's create multiple implementations of this. So let's say video processing execution, right? Let's make this an interface, and then we're going to call a simple function called run, which says, okay, so we're going to have public string start processing, and public string end processing. Okay, cool. And let's create two implementations. One we're going to call concrete video process execution. Long, it implements what was it? Video process execution. In this case, I'm going to return starting video, ending processing, right? Okay. So then in my module, I'm going to do bind video processing execution class to video to concrete. Does that make sense? I can literally come up with 4 implementations of this, switch out however I want, and I just need to make a one-line change to get how I want to execute, right? So let's do that. Okay, so this is concrete. Let me create something called funny. Okay, let's say, I hope this works. Yes, it worked. Okay. Okay, and then let's go to video processing task. We're going to add an injector on top of this. Processing task. And do inject. What's it called? Video process execution. Execution. That's not static, right? Oh, sorry. Okay, so I'm going to run it twice, right? The first time I'm going to run it, it's going to do concrete. Starting video. And, right? Now let's change this. I think I just restart, right? Restart, yeah. Okay, cool. Waiting for clients. I hope this works. Yes, it works, right? But are you guys starting to see what the difference would have been? Here, I would have had to call new, which in this case is not that bad. But imagine if this, again, had dependencies, right? Think about how many layers in Java you have, because it's very verbose, you want object-orientedness, right? But now you've literally moved the configuration up to, I would consider like a coordinator, right? So I literally can coordinate everything from this module. This is great for testing too. If for example, if there was an API, but I want to test it. I want to test it against a fake data, right? Let's say instead of actually making a request, right? So usually when you're testing, you don't want to just test you don't want to make an outbound request. You just want to pretend that sample data came back. Well, then what you would do is, let's say there was a service called API service.class. You could just bind it to a mock API service. Does that make sense, guys? It also takes care of something else. It also takes care of singletons. So I can say in singleton class. So you can, without having to implement singletons, you can literally say, I want this to be a singleton. Right? There's two ways. One, you can do in singleton. The other way you can do this is you can put singleton. I personally still prefer in here because then you can just see what's singleton and what's not. But think about it. If previously you would have to say singleton server get instance, right? That's how you would design it, right? A static function. Now you just inject the server. And every single time you inject the server anywhere, it will be a singleton. Cool? Kind of interesting? Somewhat interesting? Interesting?
But, do you guys know the root problems that people think about dependency injection? What is the problem in programming that makes people think about dependency injection?
Mention one of them. I mentioned one of them.
What happened if without dependency injection here? And what is the root problems make people thinking about this way? I feel like this question last
Maybe I think that's because in very deep, for example, in the very deep down layer, you need some kind of object, but that object must be passed from the beginning, so it's very complicated. So dependency just help you. You don't need to pass the object from the beginning. And easy to change.
Yeah, so you don't need to either. There's two ways of dealing with that situation. One is that you don't have to pass it all the way through. The second is, the other option is a lookup service, right? And you don't want to do that either, right? So lookup service would basically be saying, okay, I can look up anything, but in this case, it's clearly doing injection.
So based on this example, can you draw the dependency diagram on the board? So what is the class dependency with another?
Okay, so let's see. We have a
Based on this.
Yeah. So basically, we have what server. We have a server that depends on a thread pool, right? Which is the executor service. We also have this depends on client task, right? Right? And client task depends on video task, right? Which has another dependency on there, which is like 50, whatever the executor, right?
So in that case, I want to create a new server. I need to create new executor, new this one and new this one.
Yeah.
So then.
Yep. So it actually solves a lot of problems. It solves testing. It solves this constantly creating a new as you go infinitely deep. It also really helps with refactoring.
Yeah.
Right? Because now again, this can actually be a concrete class. It doesn't have to be an interface. But you can literally override the functions in your concrete and override. So it's a great way to like build something out as a concrete and eventually move it away to different implementations. So it's actually, it helps refactoring a lot. Does that make sense, guys? Is that somewhat cool?
Any question?
That's great.
Yeah. Now I understand more why it's called dependency injection.
Right. Now you understand why.
Because if you want to create a new object, but if depends on many other, so you you need this design button, because you will have to create another many things to create that you want.
Right, exactly. So the original way you would do is create a factory, right? And then, so it turns out factory classes are very easily recreated. So that's why they have this provider pattern. This is all generated at compile time, right? So it's like it generates all the code for you. So it's really good. Was that cool? Okay, I'm going to take a break right now. 2-minute break, okay?